What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another live stream where we try to build something cool from scratch. And today we're going to be back on some game development, working on the Crash the Stack project that we started on maybe 2-3 weeks ago. Let me check something really quick, make sure I got audio here. Always got to make sure that things aren't broken right when the stream starts. So sorry for being a little bit late today. I know this is like the latest I've ever been on any stream I've ever done. Mainly because I ended work a little bit late today and then had to rush to get my child from daycare and come home. So now we're here. So let's get it going. Before we get started, I'd like to say hello to some folks who are here today. Luis, Daigo, Kevin, Felipe, Alejandro, Emil. Thanks very much for being here, folks. All right, so today's goal is to implement basic game logic for board tile placement and tile matching. And as you can see in the next slide, not even that. I don't have anything in here because I'm so late that I didn't even get to do the slides. So let's just run through this really quickly, and I'll tell you what the updates for everything are. So off stream, over the weekend and up until now, I've been spending a lot of time. Hey, Technomag, nice to see you. A lot of time trying to get the build system up to snuff. So this is sort of like an important thing up until, or leading up to the Ludum Dare game jam on April 1st. So I'm trying to get like a full end-to-end sort of build pipeline ready so that I can be pushing updates to a game live as I'm writing it. So the updates on the build system right now is that I basically overhauled the design to make it easier to manage. And I'll talk more about that whenever it, let's see, let me do this. The mesh build design. So we'll discuss it more on Thursday, because Thursday is the day when we're going to see the sort of culmination of all this, or at least on the build side. Well, not the total culmination, but at least you're going to see it working for this game, Crash the Stack, pulling dependencies from the mesh compiler, from the Substratic engine, which is now in a separate repository, etc. So we got a few things happening here that are all going to come together on Thursday, and then we're going to build on that to make this whole auto-publishing thing that we will have for the game competition next weekend. I think that's right? Let's see, calendar. So yeah, this weekend is the 26th, and the next weekend is the April 1st weekend. So we got 1 week left to get ready for the game competition. I think we're making good progress, so we should get there in time. Also, this weekend I'm going to be out of the house, or I'm going to be going somewhere, like a family place, basically to get some rest and relaxation, which also means I'll probably get a lot of coding time. So we'll be able to catch up on some stuff then too, which is awesome. In terms of everything else, oh yeah, I guess I should say I split out Substratic. What is it like? The Substratic library into a separate repo. Let me pull that up really quickly. Substratic/engine. I'm actually reusing the old GitHub address of the previous incarnation of this, just because I liked it so much. I've decided to use it again. But it looks a lot simpler than it was before, but now I basically just got the code split out there. So if you want to track the work that I'm doing on that, you can do that there. So I've got a star already. Oh, okay. Sherlock Sloan. Nice to see you there. Okay. So what else have I done? A lot of other improvements to the language, like let's say added support for record field setters in the language. Also added support for REST arguments. So like if you want to have a function that can take in a variable number of arguments, I added support for that as well, which was pretty helpful in making the build language a little bit more fluid, I guess you could say. I'll show you what it looks like in a second. And then what else did I do? I fixed a ton of bugs. So there's even more bugs in the language implementation, but like we're at a point now where the language itself is not giving me any trouble. It's often like the libraries that I'm writing, they just don't have good error checking or bounce checking and stuff. So the language is doing great. I'm actually really surprised at how well it's operating at this point. So we're going to do a lot more coding with it in the near future. Okay, so let's move on from that. So let's add some game logic. So now what we need to do is we've got the ability to display tiles on the screen. We've got some basic tile sprites, which we made in the last stream that look pretty good. I mean, it's something to start with. Something that can actually be matched. They're visually distinct. So now we need to generate the random positions of the tiles on the board and also be able to judge whether a particular tile is playable, which means that it's I think one of its sides must be, no, one of its horizontal sides must not be covered, or it must not be covered on top either. So that's sort of the litmus test for whether a tile is playable or not. We'll try to implement that behavior. I've got a previous implementation of it for the old version of the game that I made, so we might do a little bit of cheating by copying the old code, but I can't copy it directly because it's a different type of engine. Even though it's Scheme, it's a different type of engine. So we'll try to write it from scratch to see how far we can get with it today. But I would like to get to a point either by today or the end of next week potentially where you can play the game at a basic level. You can match tiles, and you may not get to like a win or lose state, but at least you could try to do the basic matching tiles. Okay, so let's add some game logic. The rules for playable tiles are horizontal, or I guess sides on the horizontal axis. One side on the horizontal axis must not be not be adjacent to another tile, and then there must not be another tile directly on top of it, the layer above. I believe that, at least in the Mahjong games I've played before, if there's like one more layer above, then the tile is still playable. So it needs to be like directly touching the tile, basically. So let's just go on and start getting to the work on this, because I don't want to waste any more time. We're 30 minutes in. So let me go into the code. We may need to do a little bit of surgery here, because like I said, I did take out the, whoa, what is all this? That's the compiler code. I'm in the compiler folder. That would explain it. Source, substratic, that is empty now. So let me actually go delete that. So we're going to have to do something really quickly to make this work. Also, if anybody sees any trouble with the stream, please let me know. I'm still dealing with random issues here and there, which is always a fun thing. So we've got this depths folder here, but I don't think we're using that quite yet. We're still using this for compiler, but... Oh, did I actually update the build script? That would be great if I had done that, but I don't think I did. All right, so we're still cloning that into compiler folder. That's fine. We're going to do the same thing for the substratic folder now that it needs to be pulled in separately. This is going to be a headache, but we'll make it work. So depths substratic engine. Okay, and then we're gonna drop this straight in here. Let's see, a substratic engine. It would be nice to use the build system for this, but I don't think it's gonna work. Actually, I might be able to use it to pull everything down. Let's just go on with this. All right, so depths substratic engine. All right, and then also we need to do a little mkdir p here for depths slash substratic. Hey, Gavin. All right, that should be enough to get that pulling down, but it probably won't build. So let's pull up eShell and see if we can get this started. Build. All right, cool. So let's go build that shell. All right, so it built that at least. That's good. Did we clone the repo? I don't think it cloned anything. Let's see. Depths. Oh, did I do this already? I must have. Previous me happened to do some magical things. Okay, so that's already here. That's great. So now what we'll do is verify that we can build everything like we were doing before. Do we still have all the list of libs and everything? Yes, good. All right, we need that. And then right here, we need to change these paths to now be prefixed. So we're going to say depths. This is going to be a nightmare. Yeah, this is not going to work very well, because it's not built for this. Maybe I can avoid it, though. Let's see. Yeah. Let's give this a shot. substratic engine. Okay, let's do substratic slash source, replace it with depth slash substratic slash engine slash source. Yes, 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 yes. All right, so that should at least make it buildable. But we still need to pull in the right include paths. So there's this source substratic stuff here as well, so I need to change those two. So we're gonna change, oh, that's nice, if this works. Dot slash source slash substratic source. Okay. What else are we missing here? We also need the, oh, we don't need the library because we're building it straight in. Let's try this and see what happens. Oh, okay, compile. Let's see. Build sh and then bin slash crash the stack. Would have been nice if I had done this before the stream, right? Okay. Yeah. All right. That all makes sense because I made a stupid mistake here. Let me think about this for a moment. So I think if I change this so that we don't start from source dir, we actually start from maybe right here. This is all just temporary hacks to make this thing work. Then we can add a source in front of that one. Let's see if this works. Oop. Okay. Maybe let's take this off. Fatal error, renderer.h, no such file or directory. Ah. Interesting. Let me check what that folder has in it. So depths, substratic engine, source. Okay. Yeah, we'll have to change this too. This is all going to get fixed when the build system comes online because we're not going to have the same problem anymore. So engine slash source. This is going to just have to change for the moment. Oops. Okay. Does that work now? Engine, let's see. Build.sh. So I put compiler includes substratic engine PNG. Ah, I think I know why now too. I have not included that folder as well. So this needs to also go in. Okay, let's try that. Come on now. Engine, source, CGLM, glad include, depths. Oh, no. This needs to be the one. Right there. Okay. I think we are back. Undefined variable texture load. I believe that's because main needs to update its load path. Yeah, so let's say now depths slash substratic slash engine slash modules. I believe that's the case. Here we are. Okay, great. Thankfully, that did not take too long. Okay, so like I was saying before, what we're trying to do is make, we're going to randomize the board. We're going to try to set up pieces so that they are playable. And then we're going to try to have logic that checks to see whether any piece is playable. So like I was saying before, a piece that has a horizontal side free is playable. So this piece here in the corner would be playable because it has one horizontal side free. This one here in the middle would not be playable because it has both horizontal sides occupied. And then these four pieces right here also would not be playable because they have a piece directly on top, and we have to adjust for these corners as well if you have sort of like a half tile offset. So there's a little bit of logic that goes into that, and we're going to try to implement it as fast as possible if we can. So let's get started. All right, so we're going to go back into main.scm, or MSC because it's not actually scheme, as we know. All right. So we have our tiles. We have an array of tiles. We know how many tiles there are because we can count that number. So what we're going to do, I mean, one thing we need to do before anything else is make sure that the number of tiles is an even number, because you can't have a playable board if you have an odd number of tiles, because you need to match a tile with another tile. But we're not going to worry too much about that right now, I think. Gavin says, wait, you're making a game now? I thought this was about making stream animations. Well, we switched the goal for this month because I want to get on this Ludum Dare game jam competition on April 1st. So right now we're doing a little bit of game development, but it's also a good forcing function to flesh out the capabilities of the mesh language and also the Substratic library, which is going to be the basis for the other tool that we've been working on, Flux Compose, going forward. So after we get past this part of it, I think we're going to sort of, switch in and out various things that we're working on. All right, so we are going to say, I think we have an array length function. So display string append. I need a format function to make it so I don't have to keep typing string append for everything that I want to put in here. Oh, in fact, I can't do that right now because I can't format that. So let's do this. Display array length. Just want to get a read on that really quickly. Array length tiles. Display tile count. And then display new line. Really need a format function. Okay, tile count is 21, which is interesting. Let's see. Yeah, that must not be... Huh. I wonder what my other one was then. Maybe I only had... Let's see, where was that? Substratic / crash the stack. So let's see, we have the GNOME easy one, but I think it was in the small. That's 20 tiles plus, what's that, 8, 12, 14, 16, so 36 tiles. Interesting. I think I must have made a bigger one. That must be what happened there. Whoops. All right, so we may have to add some more tiles to that to make it completely right, but let's just go ahead and start it now. I'll take this tile off the top, just so we have an even number. Just should be 20 after that. Okay, tile count 20. Let's just leave it like that for now. And now what we want to do is randomize the faces. So we have the ability now to set a field on a struct or on a record, which is good because we're going to need that for setting these. Ideally, we would just generate it all at the same time, which we could do. Let me think of how I would do that then. If I had a list of positions, just XY positions and maybe the layer, then I could generate the tile face potentially at the same time. We're also going to need some randomization functions as well, I think. I believe the way that I did this before, let's see. So let me think about an algorithm. Let's see, allocate or create an array. Can't you shuffle the tiles array? Well, you can't shuffle the tiles array because you would be shuffling the positions, and they need to be ordered in a specific way so they render correctly with the right overlapping. So we need a way to come up with a list of tile values and shuffle that, and then just pick one off the top. All right, so create an array of the same length as the tiles array. Generate 2 entries for a random tile face index. Or I guess generate length divided by 2. Is that right? And then, well, I know what I mean by that. I'm not going to try to write it out in perfect English. And then, when we start creating the tiles, when creating tiles, just pick the frontmost or first remaining tile. Now, randomize the list. So randomize the tile list. Yeah, that one I'm not sure about the right way to do that. I had an algorithm for that in Scheme, but it was like functional based on lists. Might be able to steal that though if we have trouble getting it written. Okay, so let me just do this in a very methodical manner. I probably need a better way to create this list. So how about if I create a function, define, make stack. So the stack is sort of like the whole tile board. Tile positions, face count. Maybe we don't need face count, but we'll see. Now we can have a let here, and then we're gonna say tile array, make array, sort of like what we were doing before. And then we're gonna loop through the tile positions. Let's see, maybe I can make this the loop itself. So next tile. And these tile positions should look something like a list where it's X, Y, and layer. That's what we can have for now. So then what we'll do is, let's see, if pair, we also need a binding for tile positions. Tiles. Let's just say that tiles, tile positions. And then that's pretty much it. So then if pair tiles, then we go in and we make a new tile. So we can say array push. We're just going to do basically what we were doing before here. Just going to move it into this function. Make tile X. It's going to be the, let's see, the car of the tiles. But we need to pull the, I don't have like the car functions or anything right now, so I'm gonna have to do this manually, which is gonna look really, really nice and nasty. So we're gonna pull the first item off that list, and we want the car of that one because it's gonna be the first of the 3 value list. Then Y, we wanna have car, cooter, car, tiles. This is gonna be fun. And then for layer, we're gonna have car, cooter, cooter, car tiles, because we're trying to get okay, so we have this list. It's actually a list of lists. So if you have like more than one X, Y layer, then you need to get the car of the list first. And then you need to take the cooter, and then the car of what the remaining list is to get that last layer value out of there. Okay. So that should be okay for pushing to the tile array. And then I probably need to throw in a begin here. And then also call next tile. Yeah, I am going to define the most common ones, Felipe. I just haven't gotten there yet. I need to, though, because I'm having to deal with that now, and it's a little bit ugly. Next tile, we're going to put in tile array and also the cooter of the tiles list. So we're just going to get this little nice recursive algorithm going. And that's it for that side. But then for this side, we need to return the tile array. So the way this algorithm works, this is a very common recursive looping algorithm in Scheme, where you have a function that just loops over a list by looking at whether the variable is a pair, which is basically a const. And if it is, then you do whatever list operation you need to do, and then recursively call it on the cooter of the pair. And then whenever you finally get to the very end of the list where it says it's not a pair anymore, then you just return whatever the result value is. And then you get the whatever it is that you wanted from that. Now, we also need to say what the face is for the tile. And for now, I'm just going to say that it's face number 1 on everything, or maybe 0. How about that? So now we can change this whole algorithm. Whoops, define tiles. Instead of doing that, what we're going to do is just edit this whole thing. We're going to see how ugly this is going to be. All right, so I'm just going to try to block delete this. I wonder if Lispy is going to tolerate it. Okay, not so bad. I'm going to delete this as well. All right. And then we'll delete the face and layer as well. Right up to about there. I think that's good. And we also need to make this a list. And each of those need to be lists as well. You know what? No. Redo. We're going to do it this way. This is going to make it easier, I think. All right. Ooh. Kind of jacked that up a little bit, didn't it? Okay, so now we have a tiles list, which is a little bit janky, but maybe it'll be okay. So then we can actually pass it directly into the, what is it? Make stack function. And it only wants tile positions and face count. So we have 3 faces. Okay, let's not do that. Whoops. Tile positions. All right, we'll go down to below this. Define tiles. Now we have tiles as the variable that we had before. Make stack, and then tile positions and 3. Let's see if this code runs. Okay, something is crashing. I gotta get this address sanitizer stuff out of here because it just spews so much information at the end. Undefined variable pair. That's because I did not include mesh list, but that needs to not be necessary. I'm going to start adding what you might call primitive functions at some point in the very near future, where things like pair, etc., are not. They don't need to be pulled in from a module. Function requires 2 parameters. Array push. Well, yes, that's true. That is very true. So this needs to take the tile array and then press enter there. Now let's see what happens. Okay, great. That is exactly what I expected to see. So now we can get to the point where we are generating the faces randomly. So before, what I would like to see here is maybe in a list. Would it be better if it's a list? I guess sorting a list is going to be a little bit interesting because I don't have a sorting. Well, no, we don't want sorting per se. Okay, so the way I can imagine this working is I have a loop that looks at array positions. Do I have a list length function? At least it looks at array positions and checks if they're nil, and if it's nil, then it will set a value there. Otherwise, it will keep looking for another value. So that's like a really inefficient way to do this, and that's fine because we don't have all the tools necessary to do this the right way just yet. All right, so let's see. Define randomize faces. Trying to think of the right way to do this. I would like to just have it right here. So basically what I would say is faces randomize. I would have to get the length of the list, which I don't want to do right now. I'm going to hard code this for the moment. Tile count. And then let face array make array. Also, we need initially a loop to set up this array to have the right number of entries. I don't think I don't have a function yet to set something at a particular index. That's interesting. Okay. So things we're going to need, I think, array set on an array at an index and then value. We need that for sure. Trying to think if there's a way I can do this without that, though. Because the problem is, if you want to, I want to make sure that I have equal pairs. So for each face, there needs to be a pair to that face in the list. I mean, one way to do that is to make a sorting algorithm, but I don't want to deal with that right now. So it's better to just find a way to create it sorted, or create it randomized to begin with. In a stable way. So doing an array set's probably the best way because I can control it a little bit better. But maybe doing this all at the same time is not the best approach because I need to be able to check if the board is playable before I let the user play it. So I might have to generate it more than once unless I have a good heuristic for making sure that something I'm doing is not going to make it unplayable. And that's kind of hard, I think. All right. So let's say if I had this algorithm, here's what I do. I think array nth. I probably need to make this. Array nth is what I'm using right now. Array index to get the value out of it. Probably I should use nth set, which I don't like too much, but I have to be consistent one way or the other. Okay, so face array. And then for the number of tiles, I have to do a loop. So let's say next face array, remaining tile count. Okay. So then if greater than remaining tiles, remaining count, how about that? Remaining count's better name. Remaining count, no, I do not have a loop macro yet, Felipe. Predefined shuffled order in a list, loop over it and pick the elements off the array in the order given by the predefined order. Let me think about that for a second. You could if you do, you could have a predefined shuffled order in a list, loop over it and pick the elements off of the array in the order given by the predefined order. Yeah, I'm sort of doing something like that. It's just a different approach, I think. We'll see if it works. If remaining count is greater than 0, then we keep going. Otherwise, we return the face array. Okay, that sounds fine. So now, what we'll do in the next step is array nth set array, then rand I, probably. We need a randomize, a random integer function that goes up to a certain value. So let's say tile, oh no, hold on. Randomize faces, num faces, or face count, I guess. Num faces. Let's call it num faces instead. Okay, and then num faces. Randomize faces, num faces. We'll do that. Make stack. Oh, that's wrong, isn't it? Make stack tile positions. What did I put there? Oh, tile count, num faces. Okay, fine. There we go. And then we need the index for what we're setting, and that's sort of the place where we need to find another index. So we need to find a free index. Yeah, so find free index. Array, find free index. Array. Now, hold on a second. Let me think about that too. So we need a randomized number. We need 2 of them. So we need to pick one face. Place it at 2 random indices. Face. All right, so let face rand I num faces, or maybe rand int. I don't know if that's a better name for that function that doesn't exist yet. Let face rand int, and then we'll just set 2 positions. And then that's going to be array find free index array. This also needs to be sort of randomized. Yeah, let's think about that for a moment. And then that's going to be face, right? So we're just going to put the same face in 2 free locations. Or in this function, we can do a little thing where we say let next index index rand int, and then array length. This is going to be a little bit weird because we're going to be calling the same thing again and again. Array length array. Okay, so we got an index. So check if the index is free. If array nth index, if not, okay, because we were looking for nil here. If it's not free, or actually we could do it the opposite way. If it's taken, then we're going to do a recursive call. So what we can say here is next index rand int array length array. This is not going to be very performant. That's okay. When we have better code constructs, we'll do a better job on this. Okay, and then otherwise, if it is free, then we can just return index, right? So next index rand int array length array. If array nth array index that returns a non-nil value, then we're going to call next index with a new random integer. Otherwise, we are going to return the index that we already have that we know is free. So then in both these cases, this should return the next random free integer. And since we are only looping with a number of indices we know we're supposed to have, then it shouldn't create too many. Yeah. Actually, I think what Felipe said is probably the right approach now that I think about it. If you could basically have an array that just has all the indices in order, and then you just randomize that array, then you can just loop over the array and pull the indices out. But we'll do that another time. Let's just see if we can get this working. Okay, so what we need now, there's a few functions we need to add. We need to add rand int, which has a max value. So we have array nth. No, do we have array nth set? Yeah, array nth set, we're going to need that. We already have array nth. We don't need that anymore. There was something else I think we need. Maybe that's it for now. Okay. So for rand int, we're going to add that to the math library in mesh. I'm pretty sure I'm using it from here right now. Let me check this. Type checks the car encoder. Is that the latest code? Yeah. Okay, so we're going to go into the math library. We're going to add a new function for rand int. Math rand int. I'm making this distinction between that and floating point values because by default all numbers in the language are floating point. So we'll do this. Math rand int number val rand. Let me check that function because I haven't used the random function in a while. Where did that browser window go? exwm switch to buffer Firefox nightly. Okay, just disappeared. Fantastic. Okay, so c rand math.h. Okay, just gives me some value, so I'm gonna have to do the modulus. Fine. Okay, so rand as number, we're gonna say rand and then do modulus of that. And we're gonna cast it to int also. We'll need to do a little bit more type checking and whatnot on this at some point, I think. Okay, so that's good, right? Rand, what do you not like about the implicit declaration? It's in math.h, dude. Is it not? Is it somewhere else? Standard lib? Wow. Standard lib. Okay. Not what I expected. Okay. Now that seems to be fine. And we'll see. What is it like that? Yeah. Okay. So now we've got that function added. It's not happy for some reason. Too many arguments to function call. What did I do wrong here? That's too many brackets. Nah, that's why. It does have too many brackets. I'm gonna do it like this. That's fine. There we go. Thank you, code formatter. Okay, now, if I were to compile this, it's going to complain somewhere because I think I don't have the math module init. Okay, yeah, I know that. Undefined variable rand int. If I go back into main, pretty sure I have mesh math in here, so I don't know why that didn't happen. Maybe I have to, I probably have to rebuild it. I know about that warning. I need to do something about it at some point. Okay, undefined variable rand int. Rand int. Okay, that's fine. Let's try clearing it out and starting over. rm rf. I want to pull in compiler bin. Then we're going to try to